So obviously this one looks pretty different from the previous one because you got all this other stuff here. But what I'm going to recommend you, well, look at this. We're doing PEMDAS in reverse here. And I know this because there's just that one little W. There's not, now granted it's stuck inside of parentheses and those parentheses are squared. And you guys might be thinking to yourself, I know what I'll do. I'll multiply this thing out. I'll do W minus 10 times W minus 10, multiply it out. That's a lot of work. You don't need to do all that work. We just need to figure out a way to get this one little W by itself. It's just that one W, and it's the only kind in there. We can totally use PEMDAS in reverse. Please excuse my dear Aunt Sally. And so what I'm going to do is I'm going to say, okay, I got to get this thing by itself. Where's my pointer? This thing by itself. It's stuck inside with parentheses. So I got to work my way all the way up to get rid of those parentheses before I can start to solve it. So I'm going to start by looking at everything outside of the parentheses. And I'm going to say to myself, way down here at the bottom, is there anything to add or subtract that's outside of the parentheses? And right away we can see there's a 72 that needs to be added to both sides. So this is going to be left alone, W minus 10 squared. And if I add a 72 and add a 72, I'm going to have something like that. So I've taken care of this aspect of things. Outside the parentheses, there's nothing that's being added or subtracted anymore. Then I'll say, is there anything outside of these parentheses that's being multiplied or divided? There's nothing in front of here. There's nothing being multiplied or divided, so I don't have to worry about that. Then, is there anything outside the parentheses that's being taken to a power? Is there a power involved? Yeah, that squared's involved. I got to get rid of that squared. In fact, that squared is the whole reason why these parentheses are here in the first place. So once I get rid of this squared, the parentheses, they can go away, and I can start all over again. So to get rid of this squared, I'm going to square root both sides. Square root, square root. So the left side becomes W minus 10, and the right side becomes plus or minus the square root of 72. Now before I really go much further, I need to clean this up if I can. I got to think of a perfect square that divides 72 evenly, and it's got to be the biggest one I can possibly think of. So even though 4 goes into 72, and even though 9 goes into 72, the one I'm looking for is 36. 36 is the biggest perfect square that divides 72 evenly. And so I'm going to take this and write it as square root of, it's 36 times 2. This can be broken up into root 36 and root 2. And then I can square root the part that I can. So now I'm going to have W minus 10 equals plus or minus. That simplifies to 6. That I can't simplify. So it's going to look like that. And now that I've basically gotten rid of the parentheses, I can start all the way back down here at the bottom and say, okay, I need to get this unknown by itself. Is there anything to add or subtract to get it by itself? Now, there's one thing, like some kids get nervous about the fact that there's a weird number lurking over here. At this phase of the game, it doesn't really matter what this is. You know, is this by itself yet? No, it's not. I've got to get it by itself. I'm going to add 10 to both sides. So if I add 10 and add 10, this side becomes just a W. And then the next question becomes, well, can I actually, that's supposed to be a 10. It looks like a W. That's unfortunate. It's a 10. Can I combine these? These are not like terms. This is a 10, and this is a 6 root 2. This is some kind of weird number. Like, you can't add them together. It doesn't become 16. It doesn't become 4, because this is not just a plain old 6. It's a 6 root 2, and a 6 root 2 is not like a 10. So the good news is your answer can look like this. 10 plus or minus 6 root 2. And we're not going to take it any further because this is a weird irrational number that I don't quite know the value of without a calculator, and we're not doing that. So you stop there and you make peace with how gross this looks, and you say, it looks good to me. In Alex, you might need to write it as 10 plus 6 root 2 and 10 minus 6 root 2. You might need to do something like that, separated by commas. I don't know. If they have a plus or minus symbol, feel free to use it. But if they don't, you'll have to do something like that. So in a lot of ways, this is very much like stuff you guys have been doing since Algebra 1. I mean, we're basically like, they subtracted, I added. The only part that's kind of new is this weird square rooting thing. And then just the idea of like not letting this psych you out, right? Because it's just a matter of finding the perfect square rooting it, staying calm, persisting, being awesome. All those things that you know how to do already. So just do them here. Be patient with yourself. You're not going to get it on the first try, but it's going to click and it's going to be awesome. Good luck.